Good afternoon, everyone. This is our briefing to attempt to answer the question about why Mars excites and inspires us. And here to give us some answers to that is Leland Melvin, the NASA Associate Administrator for Education. Clara Ma, a student at the Curiosity Shawnee Mission East High School. She is the NASA contest winner for naming the Curiosity rover. Scott Anderson, teacher and science department chairman for the Vinci High School for Science and the Arts in El Paso, Texas. Laura Lyons, graduate student at Harvard University and a FIRST Robotics alumni. And Veronica McGregor, manager of the Media Relations Office for NASA's Jet Propulsion Laboratory. And we'll begin first with Leland Melvin.
Thanks, George. I'm just very excited to be here today, especially with educators, with students, with scientists and engineers that are helping build and ship off this wonderful rover Curiosity to Mars. And I think about myself as a child, what got me inspired and motivated to become a scientist and engineer and eventually an astronaut. It was building, developing, creating. I mixed these two dissimilar chemicals together and created the most amazing explosion in my mother's living room, and I actually put a hole in her rug. But that fueled my curiosity right there. And I think about, as the Associate Administrator for Education, what are all the unique assets that NASA has that we can share with the general public, with educators, and with learners. And so my job is to ensure that we have those types of things in place so that as Curiosity heads off to Mars, we'll have apps, we'll have applications, we'll have interventions on the website that people can go to find out more about Curiosity. But actually when it gets there, the types of things will help inspire and engage. When I think about Spirit and Opportunity, those two rovers led a very long life on the Martian surface. And now with Curiosity coming, I think it's going to be even a much better opportunity for students and teachers to get inspired. As I think about the future of our NASA organization, I think that the future is very bright. We're going to have assets that will allow everyone on this table to think about the future and the next generation of explorers. And so with that, back to you, George.
Thank you, Leland. And now to Clara Ma from Shawnee Mission East High School. She was the NASA contest winner for naming Curiosity. Clara?
Hi, I'm Clara, and 3 years ago, I was sitting in my 6th grade science class reading an article about NASA's two Mars exploration rovers, Spirit and Opportunity, and also the contest to name NASA's next Mars rover, the Mars Science Laboratory. And sitting there in class, I immediately began to think of names for the rover, and the first name that came to my mind was Curiosity. And I thought of a bunch of other names that were really cheesy and none of them really fit. So I kept on coming back to Curiosity because Mars is such a mysterious and wonderful planet, and it inspires so many questions in all of us. And I think even though Mars is millions of kilometers away, I believe that it manages to inspire all of us in one way or another, whether it's the color, the vibrant red color, or the craters, the canyons, the mountains, the volcanoes, or the science. And I think that I'm just so lucky to be here, and I hope Curiosity makes it there safely next August.
Thank you, Clara. Now Scott Anderson, a teacher and the science department chairman at Da Vinci School for Science and Arts at El Paso. Scott?
Thank you. I was thinking back to what inspires me, and I still remember back in the exciting days of the Mercury program when I was a little boy, and my dad woke me up at a very early morning because we live in Arizona and a comfortable launch time in Florida was very early for us. And he got me out of bed and we waited through all those T-minus so many minutes and holding. And then the clock would run some more. And then it would be T-minus 10 minutes and holding. And we held, that was the longest 18 minutes in history. But we were there for Alan Shepard, and we were there for John Glenn, and all those boys. We got them off, and we gave them the moral support from Nogales, Arizona, from a hilltop about 1 kilometer inside of this nation, right by our neighbors in Mexico. And we were there for them. And if Dad hadn't gotten me out of bed and told me, hey, we're going to watch the launch, I don't know if I'd be the Martian wannabe that I am today. Now I brought my granddaughter, Nicole, who's an 8th grader. Nicole Harrison is here, and she's with another group of students from Alabama touring the Space Center as we speak. And she's the next generation of explorers, and she wants to be one of the moving parts of this great endeavor. And my Uncle Joe worked in aerospace, and I tell my students that hardware he worked on is still sitting on the moon today. And that means a lot to me, and I think that wakes them up a little bit. Said, yeah, we of course, there's a myth that we never went there, but I debunked that right away. And now I've been attending Mars education conferences over in Tempe, Arizona for quite a few years now. I'm a frequent flyer with them. And they had me at the first go. I got a little note in my cubby at my workplace in Nogales and said, come on up for an educator conference. It'll cost you $5. And I figured it's only 180 miles. I can be there by 8 o'clock and on a Saturday morning. And sure enough, they had me. They gave me a topo map of Mars from the laser altimeter, the MOLA instrument. And I got to meet a principal investigator for one of the instruments there, and they had me from the get-go. So I've been a frequent flyer. But what I've brought back from those conferences, and I recommend to any teachers that can obtain those materials, and we all can, to use some of those. There's Mars Uncovered is a wonderful way to study basic geological processes, and those laws of nature are the same, both planets. And we study comparative aging techniques, and it brings it home. So we can do it both ways. We can use Earth to study Mars. We can study how things work here and figure out what's going on there. And then we can use Mars to study Earth and say, what went wrong with their climate? It's not as nice as we'd like. It's not like the Ray Bradbury novels that I read, the Martian Chronicles. It was a shirt sleeves environment in those stories. It's not quite that user-friendly now. But definitely, we've had some very good student enthusiasm by bringing those real materials and say, these things are real. It's a real place, and it has as much dry land as Earth. Okay, no water ocean, but there's water there. We have natural resources there. There's carbon, there's oxygen, there's water and iron, there's sunshine, there's an atmosphere. What really, one of my teacher friends was teasing me the other day. So he says, Scott, so one of your big problems in life, one of the things that really gets you down is that Mars has no good magnetic field. I said, that's right, honey. So I'll take the problems I have instead of some that I don't. But let me tell you just a little bit about some of the projects that I've done. Could I have a slide? We did a grade level wide project. We have a capstone project at Vinci School in El Paso. And we've wrapped up the school year with a themed project, and the different grade levels do different things. And last year was about bridges, and some designed bridges and built bridges. And mine, I managed to work in our NASA affiliation with the Bridge to the Future, to our next home. Now, Earth is my favorite planet, but Mars is my second favorite. And I hope that we'll be living there and have community there soon. I sure want to see that. I want to see some boots with red dust on them. So let's get with the program, and curiosity is our next step along that road. The Bridge to the Future, so they made this little example to start that. Could I have the next slide? We did research, and the students here are looking up basic information and preparing notes there at the computer lab. Next, please. And this is about community. We decided to study the community we live in and see what we value about it. What are the positive aspects? What are negative aspects that we could deal with or try to eliminate in a future setting? And so they came up with human values and the assistance to one another and so on. Next, please. Then we got into designing specifics about our proposed community. And they came up with a name for it of .com. The dot stands for Mars, and the com is community on Mars. Okay, so that's and then they had the specific location where the first dwellings would be. They called it Marsonia. And we developed our own flag, our own creed of coexistence and mutual support. So that kept the kids very, very positively occupied and broadened their horizons quite a bit. Next, please. So this is them working on some of they had the patch, the mission patch to go on up there, and they designed proposed patches and then voted on the winning patch. Next, please. These are some of the artworks that related to, you see a little green Martian there, and the bridge to Mars and so on. But they were able to, while painting and modeling clay, let their imaginations expand to, yes, this is a real possibility. And I know I'm just a kid now, but there's a possibility for me in this positive future environment. Next, please. A couple of future Martians there. And working, displaying one of their little models. They made model rovers and spacecraft and such. And the last slide shows they're putting together a mock-up of some vehicles there. So this was very positive, and the NASA program lesson plans were quite detailed and specific and very user-friendly for teachers and kids. Okay, I'd like to mention another one. I mentioned Mars Uncovered. One that I want to participate in this year is the Mars Student Imaging Project, where the students can actually task an orbiting spacecraft around Mars to take a picture of a specific site they feel might be of interest, and then do science analysis of that image. And they really are scientists at that point. Of course, all kids are born scientists. You know, they're all exploring their world and analyzing why did I fall down? What's the problem here? So the STEM fields are all dealt with very nicely in the projects that have been recommended through the education conferences. My school is very involved with engineering, and we're partnering with NASA partners both in Houston and also at the University of Alabama in Huntsville to create a mock-up and a full process for a package to be included on a mission to Mercury. We'll be doing that this spring. So they allow us the full range. What's your question? How will you attempt to answer it? What is the process? And then their project will be judged as to whether it's worthy or not to be included. They have a certain constraints, mass, energy, and so on, all these constraints. But I tell you what, I just had to bring my little rocket scientist down here to show her in person what humankind can do when we work together. And I think this place is a fabulous example of that. And thank you.
Thanks, Scott. Now to Lauren Lyons, a graduate student at Harvard University and a first robotics alumni. Lauren.
Thanks, George. Yeah, I remember growing up as a kid in Compton, California, and, you know, I didn't know what I wanted to be when I grew up. I didn't know what an engineer was. I didn't know what any of that stuff was. But my high school got this first robotics program. And my initial interest was based on the fact that the championship at the time was held in Florida, in Orlando, and that meant a trip to Disney World, all expenses paid. And so I said, hey, I gotta sign up for this. What was interesting is JPL was right around the corner. So they sent their engineers out to help mentor us. And then I started thinking, wait a second, this robotics stuff is pretty cool. I can actually do this. I'd never been one to be incredibly interested in math and science before, and it was for no fault of my own or anyone else's. It just hadn't been exposed to me. And so, after, I believe, 3 years of FIRST Robotics, I decided, I'm going to do this. We took some trips to Kennedy Space Center every time we were here, being able to see just the space shuttle buildings and looking at all the museums and just learning about the history of space just really inspired me tremendously. Ended up going to space camp, said I'm going to be an astronaut now. Applied to engineering school. For some reason, they let me in there. I think it had to do with FIRST. And studied mechanical and aerospace engineering and continued to mentor FIRST teams while I was in school. Luckily for me, due to some wonderful mentors involved in FIRST, I got an opportunity to intern at JPL for 3 summers, working on the Mars program. And just being able to look at the clean room and see Spirit in there before it launched, and just feeling like I'm a part of that, even though I had a tiny, tiny role as an intern over the summer for 3 months, just knowing that a little bit of something I did is involved in this massive feat of mankind sending this beautiful machine to space is just incredible. After my time at JPL, I went to work as an engineer for a few years, 4 years actually, in the biomedical sciences. And as George mentioned, I'm now at Harvard University studying public policy, specifically science and technology policy. And for me, this is so important. I hear people say, what's so important about space? No one denies that it's cool, but what is the real value in spending money on this? And this totally excites me to be able to talk about the importance of innovation, the pull-through that comes from space studies, and the spin-off technology. And for me, the biggest thing is how this inspires young people, how it inspired me. It inspires us to think of something bigger than ourselves, to think about becoming a scientist or an engineer and exploring things outside of the easy, the typical. And I think that, having this education is going to empower me to continue to spread the word about how cool Mars is, how cool science is, how cool technology is, especially with girls and women. Yes, getting them out there and having them understand that, you can do this too. In fact, you can do it very, very, very well. And I feel like I'm living proof of that.
Thank you, Lauren. Now, Veronica McGregor, the manager for the Media Relations Office at the Jet Propulsion Laboratory. Veronica.
Thank you. I'm here to tell you that if you are already out of school, it's not too late. There are still lots of ways that you can become involved with the NASA missions. And we are very fortunate at JPL. We're exposed to Mars every day at work. We get to see rovers being built in our clean room. And I think every one of us who has ever worked there thought, if only we could bring everybody else in here, if only they could see what we could see, we could change everybody and they could become interested in this. So in the last few years, since we landed on Mars in 2008 with Phoenix, we also landed in social media. And we ended up on Twitter and Facebook, and we've used many different venues to try to bring the public in and have more one-on-one experience with what we are doing, whether it's talking to a scientist over Twitter or doing a chat over Ustream. We've looked for more and more ways. And one of them was to do a NASA tweet-up. We started this at JPL in 2009, right after the Phoenix mission ended, because there was such a tremendous interest in Mars right when that ended, and we wanted to keep that momentum going. And we thought, let's bring in 120 people to JPL and let them sit down with the scientists and engineers who worked on that mission, and let's show them this rover that's being built right now, Curiosity, when it was just a box. Let's show it to them so they can see what it's like, and they'll be able to follow this mission through its lifetime. And we didn't realize how successful this event would be until people from around the country and around the world, in fact, applied to come and spend 2 hours at JPL talking face-to-face with the mission team, with the scientists and engineers. And since that time, we've held now 31 NASA tweet-ups at different areas around the country, and there is one taking place right now down the hill from us in the big white tent, where we have 150 people. They represent 37 states and 10 countries that have flown here on their own dime and staying on their own dime for the opportunity to spend a few hours with some of our scientists and engineers, and even the administrator of NASA tomorrow will talk to them. This is bringing people in and letting them finally have that really direct opportunity to be involved in a mission and ask us questions. And we don't screen. We get asked every kind of question. But let me show you a little bit about what a tweet up looks like. I can talk about it all day, but I've got to show you a little bit of it in fact, in their own words as well. If you want to roll the first video, I'll give you an idea of this is the tent. This is actually from August. We held a tweet up there also for the Juno launch. This is what it looks like. It's 150 people with all of their electronic devices laid out on the table. You'd think it was sort of like a press room, but this is sort of the citizen journalist room. And now they are posting messages to Twitter and Facebook, their blogs. They're taking pictures, putting them on Flickr and all the photo sharing sites. And anyone, the reason we do this is 150 people are here, but anybody can follow what they are seeing and what they are learning by going to Twitter. And I'll give you a URL if anyone wants to bring this up on their computer. It's very simple. It is www.twitter.com/search/NASA tweetup. If you go to that page, you will see right now all the posts that are being put on Twitter in relation to this tweet up taking place today, and I've asked previous attendees at our tweet ups to please post something that they learned during the time that they spent with us, or some action they took after they left, because we have seen that they go on to do amazing things. They go on to organize public launch parties in their communities. They go on to talk to schools and children, and they want to share the knowledge that they get from us in the short time that they're with us. The tweet ups can last anywhere from 2 hours to 2 days. The one taking place at Kennedy Space Center right now is a 2-day tweet up. They'll actually be able to go out to the launch pad in a little while and see the rocket. And tomorrow they will be here at one of the best locations that anyone can be to watch the rocket launch. Let me show you a little photo album of pictures that previous attendees have taken and put together. This is some of the different things they get to do, talking face-to-face with astronauts, going to Wallops to see some of the rockets, face-to-face with some of the rover drivers, learning about missions to Jupiter, talking again with the administrator and really giving him some good, tough questions. Hands-on with some very cool products for space, 3D imagery and visualizations that help people see what we are seeing in space, and then seeing Curiosity being built in our clean room and all the time posting that information for others to know what they're seeing and learning. They've gone to control rooms at the Johnson Space Center. This was the Juno tweet up out there at the launch pad watching that rocket, and the next day watching that rocket launch. These are the things that we want to make available to the public, and I encourage everyone to follow NASA on Twitter to be able to know when we are announcing one of these opportunities. When we announce the opportunity, there'll be a registration period. We get thousands of people registering, and it's a random selection of 150 people, in most cases, to come to the center and do this. Now, not everybody can maybe pack up and leave and go to a NASA center to see this, but I want to tell you there are other ways you can get involved and get some more firsthand experience with these missions. For this particular mission, we actually put a camera in our clean room, and for 9 months we broadcast what we called Curiosity Cam. And there's, we didn't want to show you every day, but we sped up 3 or 4 days very quickly. People could come and sit and watch not only the rover being built there, but we also maintained a chat box for 3 hours every day, Monday through Friday, for 9 months, where people could come in and watch it being built and then ask us what they were seeing and ask us questions about the engineering and the science. And we often had team members come in and also help answer some of those questions. So more and more we're looking for ways that we can reach out to you, but we want you to reach back into us as well. And so we really hope that more people will sign up for the next future NASA tweet up. And as I said, follow us at on NASA on Twitter, and you'll be able to learn all about them. Thank you.
Thank you, Veronica. And we're ready now to take questions. So please give your name and affiliation when the microphone comes to you. Okay, right here.
Question for Leland Melvin. I'm Mark Ratterman with Talking Space. Do you think the NASA Tweet Up experience will help increase focus and emphasis on STEM in the short term, or will it take a while?
I really think that the tweeps, as we call them, as they get this message out into the Twitterverse on science, technology, engineering, and mathematics, will help in the short and the long term. I have seen where I've done tweet ups before, and people have contacted me on my AstroFlow account and say, how inspiring that was, how impactful that was, and they're also going to spread the message to other people. When we were at the World Science Festival in New York, I guess a couple of years ago, Sandy Magnus and I were doing a tweet up there, and people were seeking me out to tell me that, hey, I'm going to go into teaching now because I want to take this message forward to help others and help inspire that next generation of explorers. So I think when we think about Curiosity going to Mars, I think this 8-month period between launch tomorrow and when it lands will be an opportunity for us to even do more with the social media to help more people get involved and to understand what it takes to send a rover to the Martian surface.
Go ahead.
Oh yeah, hi, Mike Wall from Space.com. This is for Clara. So yeah, like you mentioned, Curiosity was the first one that popped into your head, but there were some other cheesy ones floating around in there too. What were some of those? I mean, do you remember them at all?
It was like inspiration and like stuff like that. But I thought Curiosity was just the best fit that, because like Mars is just so inspiring and it inspires curiosity and questions, and I thought it was just the idea of Curiosity, like roving up there on Mars, that was just perfect to me.
Hi, Robert Perlman with CollectSpace.com, and if I can follow up on that question for Clara, what has been the impact to your life of being the person to name a Mars rover?
Well, my friends think it's really cool, and I've gotten to go to so many places. I went to the NASA headquarters in Washington, D.C. in in the year that I named the rover, and I'm here, and I also went to Disney World, which was really fun, and I've just gotten to do so many cool things and be a part of all of this, and I kind of feel like I'm kind of part of the family now. And it's just been an amazing experience. I'm so honored to have been a part of it.
And for Leland, you mentioned at the beginning apps, and so is there a Mars Curiosity app in the making that NASA is going to release?
Yes, I think there are 2 apps, and I don't have the website yet, but we will get that out to the masses very soon.
Okay, I think we have a question over here.
Gene McCullough with Talking Space for Veronica. I'm being a veteran of a few of these tweet-ups myself. I'm just wondering, too, have there been any studies as far as the impact that they have had thus far, anything formal? 'Cause I'll be blunt, the organization that myself and my colleague Mark here was born out of one of the NASA tweet-ups. So I was just curious if there was any informal impact study as far as what's come out of them.
That's a really good question. One of the reasons we use Twitter is because most of those pages are public, and it's very easy for us to go in and see how many messages went out and to what size audience. It's easier than other social media venues where people keep their accounts private for very good reasons. So I can give you an example for the Juno launch. We know that we went back and analyzed how many messages were disseminated about the Juno mission and the Juno launch overall through Twitter during the week of that launch. And overall, through Twitter, there were about 90 million messages that went out around the Twitterverse and being picked up in blogs that talked about the Juno launch. And then we isolated to see how many of those were NASA tweet-up-related tweets. And those accounted for about 30 million. So when we look at that and say 150 people and usually talking to friends and neighbors and they don't have giant accounts in the millions like some news media might have, but these are just regular folks sending out those tweets and hitting 30 million people, and the rest of the world got the other 60 million. I mean, it's a huge amount. 30% of all those messages came out of the tweet up. So those sorts of things really inspire us. And then all the stories, we get back the most amazing stories. So exactly like yours, that people go on and realize that there's something they can do. You don't have to work for NASA. There's something you can do in the field. You can, or you can go and do public programs. And it's really, people tell us it is life-changing for them, and that's it's amazing for us. I think early in my career, we always used to think if we knew that we had changed one person into having interest in space science, we'd feel like we'd accomplished something. And we don't have to think about one person anymore. We can think about, tens of thousands and millions. It's very exciting. Thanks.
Any further questions? Over here, right here.
Jason Ryan from americaspace.com, and this goes out to Clara. If I had to pick out two looks that I've seen across your face in this press conference, it's shock and thrill. You just look so happy to be here and so surprised at all the attention you've gotten. I was hoping you could probably give us a little bit of a background of what your life was before you named Curiosity and what it's like now, and perhaps what your goals are like now as opposed to what they were before.
Before I named the rover, I was just a sad little girl, and I sat at home. And, well, actually, naming the...
You sat in your room.
Yeah. But naming the rover has been an awesome experience. I've learned so much from it. I've learned a lot about Mars, but I've always been interested in space and space exploration. And getting to name the rover just made it so much cooler. And after naming the rover, it's just, I've been following Mars and Curiosity and on Twitter and on Facebook, and I've learned it's just been so rewarding for me. And after naming the rover, as I mentioned before, I got to go to a bunch of places and meet a bunch of people, like Leland here, and he's really cool.
I didn't pay her.
Yeah, it's just been such a great experience for me.
We have a follow-up right here.
Mark Ratterman from Talking Space. A question for Laura. As far as excites and inspires, can you think of something from your studies in public and space policy that when you've learned that and discovered it, that it was something that had you surprised and excited in a positive way?
Yeah, I'm taking a course right now about technology, innovation, and economic growth, and just seeing the correlation between money spent on R&D, domestically spent on NASA, when those budgets are sort of aligned, just sort of the pull-through that comes through with the economy. And just looking at economic rationales for promoting science and technology. In the past, I feel like I didn't have those tools, and so I just say, it's cool, and nobody can deny it's cool, but to be able to say, no, it's more than just cool. In fact, it's really good for this country, it's good for the world, and to make the economic arguments, things that are just pretty black and white, and show the history from, the Industrial Revolution till today, I feel really empowered by that and inspired by that. So it's not just me being a cheerleader. Now I can say, okay, I'll cheer, but I also have a little document here which tells you why it's the truth.
You certainly may.
I'd like to follow up on that. I couldn't agree more. One of my fifth grade students the other day said, well, isn't that a lot of money for gas to send something up there? And yeah, there's gas and there's more expense too. But I explained to him that we don't send the money there. We spend the money here in places like California and Texas and New York and Florida and Ohio and all of those places. And we also develop what has created a wonderfully great country. We develop science and technology. And that if we stop developing those things and let other nations take the lead, that we're just going to be dropping farther behind all the time. And so we might as well spend the money here and get the bang for the buck that you just described.
Any further questions? We have one right here.
Yeah, Roger Eckert, the Arcade Eye. I have a question for Clara. Can we look forward to seeing you here in the future as a scientist?
I hope so. I'm so interested in astrophysics and space, and that's definitely something I would like to try, maybe. And I hope I can come here and work.
Or maybe go to Mars.
Yeah, or go to Mars, yeah.
There you go.
Stefano?
Stefano Coleda for Italian radio and TV, and also as an educator. I was wondering, the other day I was listening to the radio, and I heard that 30% of the foreign students in this country, obviously at college level or graduate level, are from China. About 15% are from India. It looks like, compared to this country, which seems to have almost lost the excitement or the enthusiasm concerning research and space exploration, just because possibly America has already been to the moon. Other countries consider this a lot more important than the United States, and they seem to be, running and bounds and leaps ahead eventually of the United States. And I'm wondering what your reflection could be about this.
This is directed to you.
I'll speak on that. I'm at Harvard, and I take courses at MIT as well, and I see this firsthand, what you're describing. I do think right now there's a bit of a shift going on culturally. This is just my intuition here. I don't know for a fact, but enabling communication, whether it be through Twitter, through Facebook, reaching out to people and making this more accessible, I think is a huge part of it. And, when I was looking for jobs graduating from college in 2005, you go to the career fair, and this is no fault of my university, this is pretty much kind of standard. I saw every investment bank I could imagine, and I'm just like, where's the JPL booth? Where's the NASA booth? Where's the Engineers Without Borders booth? And I couldn't find them. And I think that, obviously with what's kind of going on in the economy, but I think in general there is a shift happening, and I think that, that's no longer just the safe route when you finish school. I think a lot of work needs to be done, and there's a lot of research out there that shows, you have a lot of people coming into college saying, I want to study math, science, and engineering, and then they drop out of that and go do something else. I think there's huge opportunity there to inspire these students to continue on, and this is through evolution in engineering education, through science education. There's a lot of stuff happening in education to sort of change the way we teach these things. So I'm not an expert on this, but these are just some things that I see changing in the world right now, and I think that it only helps the STEM cause.
I'd just like to add another piece. If we start in the middle school, I think we lose a lot of students in the middle school age range. And if you don't have something that's inspiring or motivating for them to latch onto, then they're going to not even turn towards science and engineering. And we have Scott here, who's an educator, and I talked to about 70 educators this morning, and I said that, you can only inspire someone if you're inspired yourself. And so one of the things that we're doing in NASA education is to ensure that the unique assets that we have to offer from NASA, whether it's, curiosity, whether it's flying K through 12 teachers on a zero-G flight at JSC to let them know what it's like to be flying and floating for 25 seconds in microgravity 33 times, we give them that inspiration and that excitement, and that will help fuel this interest in STEM, and they can take that back into their classrooms. But I definitely agree with everything that Laura said. When I was in graduate school, there were a lot of foreign students there, a lot of those students that go back to their countries. But we have to let our students in the U.S. understand that even though the shuttle program is over, we still have a very vibrant space program. The International Space Station's been on orbit for many, many years and is continuing to flourish, and we have someone living there 24/7. So making these opportunities and assets aware to the general public through Twitter, through Facebook, through these social media networks, and ensuring that the media, you guys that are sitting out there, let people know that the space program is not over just because the shuttle retired. So those are some of the things we need to make sure we do.
Can I say one? As a parent, I wish schools would celebrate their first robotics team as much as they do their football team. I think as a culture, we don't celebrate our kids when they're doing really extraordinary things in science and technology, and they see the other areas where they are celebrated. So I think as a culture, it would be nice to see people turn more. Please celebrate the kids that are doing the robotics, celebrate the kids that are doing, after-school engineering programs, just as much as we do everyone else for football or any other sport.
Okay, Stefano, you have one more follow-up, and then we'll come over here to this side.
Yes, a quick follow-up. It looks like, to me, it almost the human mind turns, people become blasé pretty quick. It happened, seemed to me, with the space shuttle, and by Apollo 16 or 17, interest already had gone down quite a bit. It looks like as long as something is new, there's a lot of interest, and then at one point it peters out. I don't know. Obviously, you're not a psychologist, I don't think. So I'm just trying to throw this out for people to debate and think about, because I think it's an important point.
I'd like to take that. I'd like to say that early on in education is a great time to get kids, young humans inspired, and then we tend to lose them as we go along. And then we have a whole entry cadre going into college, and it seems like the mindset in a lot of colleges is to weed them out, whereas we need to inspire them to take that next leap. And yes, you're going to have to take some hard math classes, but there's a reason for that. And if we started off with more problem-based education, or that they had an end goal in mind, such as some of the projects I've seen at the School of Earth and Space Exploration at ASU, is that they start out as a group, go out and study their various specialties, and then come back together as a group, and they have that 4-year block laid out for themselves. I think a lot of colleges could take that in mind and say, instead of taking all the dry stuff in the first 2 years and losing most of your kids, let's get some project-based education going on early on and really turn them on. And those switches and those lights will come on and say, yes, this is cool. Okay, and we have an end in mind, and I can be part of that career. And yes, I'm willing to slog through that calculus class and make sure that I can continue.
Yes, Greta Holby from Ardea Arts with the Three Astronauts Project. I was responding very closely with what Scott showed us on the video, which is kids involved with the arts as a way into science. And I think that that's very important. We keep talking about Twitter and Facebook and social media as a way to engage people, but the arts have always engaged people. And not only that, but the arts in all sorts of ways, as far as entertainment, music, art, in all sorts of ways, reach millions of people. And that's a way to inspire our generations. You're taking courses at MIT. I actually went to MIT, and one of the things that so inspired me at MIT was that it was like the arts, and the arts held an equal position with the sciences. And you'd come into your classes, and the professors would be coming out having worked on the solar panel of the, and it was just extraordinary. And I think, as Scott was just saying, we have to have that excitement in our educational system. The problem with most science, the way it's taught, is that it's so dry and so by the book. And I feel as though, we keep saying STEM, but I feel as though if we can start saying STEAM and put the A into the educational, the arts is an extraordinarily fertile place to ignite creativity, which is what we need for the sciences. We can't just learn the sciences, we have to approach it from a creative well. And I really feel as though we should be saying STEAM here, and we'd find a lot more people interested in science.
Go.
Greta, one of the things that we're trying to do in education is to partner with people, like-minded people. We met with the Lincoln Center Institute just about 2 or 3 weeks ago to talk just about how we can motivate students in the arts to see that there is science, technology, engineering, and math in everything that we do. And when I flew in space for my first flight, I took up Quincy Jones's, one of his CDs. And when he interviewed me while I was in space, Quincy so eloquently said, there is math and music. For both of those two things, it uses both the right and left side of the brain. So if you know math, you know music, and if you know music, you know math. But we don't show that in the classrooms. There's a big divide. You got an art class, and then you got a math class, and they're not connected. So if we can start showing how these two, what seems like dissimilar things, are connected, more students will then have this more of a Renaissancean type flavor in their education, and they will look at, music and art and science as a combined thing, not just separate pieces. That's another thing we're trying to do, is to bring in entertainers. I've worked with Mary J. Blige, will.i.am, who's put a lot of his resources into first robotics and an ABC special, because the technology part of it is so important, and he wants to celebrate. He's coming here to help celebrate this with us tomorrow after Curiosity launches. But using musicians, using ball players, the physics of football we were taught into Donovan McNabb's football camp. So we were coming in on the back end, teaching kids that if you know physics, You know, when you drop down and your center of gravity gets lower, you're going to be a better ball player. So how do we use all of these different ambassadors, these trust agents that students look up to, ball players and rappers and musicians, to help them sell the STEM message? And I know you say STEAM, I know the arts is in there, but STEM is in everything. It's in everything we do, and it's very important that we make that connection.
Thank you, Leland.
Just one follow-up is that you have that NASA has that extraordinary program now with non-traditional partnerships, and certainly we've been working on our proposal, but I think that that's a very exciting new direction.
Thanks.
All right, that will conclude this briefing. This is our last of our briefings that we've had throughout this week on the Mars Science Laboratory. So our next activity is going to be launch, and our coverage starts in the morning at 7:30. Thank you.